Hello there, this is lesson 6. We're going to analyze exponential graphs. This will really help in future courses. Plus, when you have to graph something without a calculator, this will help give you some clues. We've seen a wide variety of equations and graphs, so moving forward, we want to distinguish between the difference of exponential growth and exponential decay models. It's really important to consider the behavior of the function in relation to the horizontal asymptote. And by that I mean whether it's moving toward the horizontal asymptote or away from the horizontal asymptote in the positive direction. Excuse me. We've seen these formulas so far in our chapter, and they normally represent growth or decay. I need a drink of water. Hold on a minute. So here you have, if the k value is a positive number, you have growth, and here's the population model. If you have a positive r value, like 1.5% or 2%, then that would be population growth. And then this is our formula for continuous growth or continuous compounded interest. You've also seen it as y equals PE to the RT power for the amount of money earning continuous growth. Then if you have a decay factor, then this would be a negative k value or a rate of growth. And if you had subtracted from your initial amount, you have population that's declining. And then this one we saw was Newton's cooling law. So we need to find the behavior of a graph without using a calculator. But we can use the rules of transformations and the rules of exponents, and we can find patterns that will help us graph. So let's go look at a few of those. Remember that exponential equations can be written in this form where you have a times a base, and x minus h is going to move a graph left or right, and the k value is going to move the graph up if it's positive and down if it's negative. So in this unit, we've seen these following rules without considering the behavior of what happens if you have a negative a value. And that's what we want to explore, the effect of negative coefficients on x. What does that do to the behavior of a function? Okay, so let's look at this one. We have y equals negative 1/2 to the x power. In this case, we have a negative a value. Actually, I'm going to write it that way. Y equals negative 1. And our base is a fraction. So when the base is a fraction, the graph is going to be reflected across the x-axis with the a value being negative, and it'll be concave down. We also have 0 for our horizontal asymptote, so I'm going to sketch that in there. And then my graph is going to go through about here. It's going to increase and then go toward the horizontal asymptote as we move to the right. So at x equals 0, that's our horizontal asymptote. We have the domain is all reals. We have the range goes from negative infinity to 0. And then I can look at the graph and I know that the a value being negative caused the graph to reflect over the x-axis. Reflect across the x-axis. The graph is concave down. It's increasing. Okay? So what normally would have been decay this way, the negative here flipped that graph over the x-axis. And then here we have another one where the a value is -1, but this time the base is 2. So the graph is going to be reflected across the x-axis again. The horizontal asymptote will be at 0. But this time it would have been, without the negative on the a, it would have been exponential growth, but now it's going to flip the other way. And we would have decay. It would seem like decay. And the graph would go something like that. I could make a table, but I'm going to pass on that. So at x equals 0 is our horizontal asymptote. The domain is from -infinity to infinity, so all reals. The range is from -infinity up to 0. Let's see, what all did I write on the other one? We reflected across the x-axis. The graph is concave down. It's decreasing. Okay, can we say anything else about it? It's pretty much the same thing that I did on here. All right. So there's 4 different versions of exponential function behavior. And I know it's written in a paragraph in your notes, but I'm going to spell them out in 4 steps here. We can either have positive growth or negative growth. And we can also have positive decay or negative decay. So here's an example of positive growth. You put money in the bank and you invest it, or you put money in a mutual fund or the stock market and the money grows. That's positive growth. We can have negative growth. And I'm thinking right now about the debt of the United States. It's getting worse every day with all the spending and coronavirus funding. We can have positive decay, like when you have the half-life of a radioactive element. You start off with a lot of radioactivity, and then that declines. And we can have negative decay. That would be like paying off half of your loan in the first year, and then a quarter in the second year, and an eighth in the third year, and so on and so forth. If you followed that pattern, you would never really pay it off, but you would get really close to 0. So let's look at those types of graph. This is an example of positive growth. My A value is positive, and my base is bigger than 1. The graph is concave up. The graph is increasing as we go to the right. As x goes right, y goes up. So it's an increasing graph or an increasing function. You see it's above the horizontal asymptote. And I like to think about it this way, positive growth. As you move to the right, your function is moving away from the horizontal asymptote. So it's positive growth. When the base is bigger than 1 and your A value is positive, that would be growth in a positive direction. Here's decay in a positive direction, and here's how I'm seeing it as decay. Before I say the base is 2, I want to rethink how 2 to the negative x power could be written. So really we want to resolve that negative on the x. I want to have ab to the x power, no negative. That means that my base is really 2 to the negative 1, which is 1 over 2 to the positive 1. So we resolve the exponent being negative before we start to decide what type of a graph it is. This tells me A is positive, 1, and B is a fraction. It's between 0 and 1. So I have a decay function, but in a positive direction. The function graph is concave up. When x goes right, y goes to the horizontal asymptote, and in this case the horizontal asymptote is 0. So you notice I'm moving toward the horizontal asymptote as we go to the right. Concave up, it's a decreasing function. It lies above, the graph itself lies above the horizontal asymptote, right? So this tells me I have positive decay. Now, here's negative growth. How do we know we have negative growth? The A value is -1, and the factor, our base, is 2. Our base is bigger than 1, so it's a growth function, but it's growth in the negative direction. See our asymptote here at 0? The growth is happening in the negative direction. We're moving toward the asymptote in the negative direction. We're moving away from the asymptote as x gets larger. So our graph is concave down. We're concave down. The function is decreasing. When x goes to the right, y goes down, down. The graph lies below the asymptote. This is growth in the negative direction, so we're moving away from the asymptote. It was this type of a graph, but the negative on the A flipped the graph over the x-axis. So this way is growth, but when the A is there, that's the effect of that negative value. Doesn't change the fact that the base is 2, so it's a growth function. It's just that the growth is toward the negative. And then negative decay, we have 2 reflections. We have first that the A value is negative, and then we have the fact that the base is really 2 to the -1, so the base is 1/2. That means my function is -1 times 1/2 to the x. That's how we end up this way. Horizontal asymptote at 0. A negative A value and a base that's a fraction between 0 and 1 gives us concave down. So the graph would be increasing. And we can compare that also to positive decay would be like this. It would be a decreasing graph. But with the negative on the A value, it flips that decreasing graph over the x-axis. It becomes an increasing graph. And what was concave up is now concave down. So when x goes to the right, y is going to move toward the horizontal asymptote. The graph still lies below the horizontal asymptote, but this is negative decay because the base is 1/2. Here we can complete a table to kind of summarize what we just saw. When A is positive and B is bigger than 1, the base is bigger than 1, we're going to have a function that increases, and B is going to be exponential growth. But when the A value is negative, the graph won't increase anymore. The graph will be decreasing. and the B is still going to be exponential growth. It's just going to be exponential growth in a negative direction. Then when A is positive and our base is a fraction, somewhere between 0 and 1, a number between 0 and 1, we would have positive decay, so the graph would decrease because that would go this way, or this one would go this way. And this one would go this way. And this one's going to go that way. So we're decreasing. And B is going to be an exponential decay factor. And then here A is negative. So we're going to flip that graph over the x-axis or over the asymptote. And then the graph would be increasing. And our B value would be exponential decay. Now, one thing I would add here, when your A value is positive, we could even write it up here. If A is a positive number, that tells us the graph lies above the horizontal asymptote. And if A is a negative number, then our graph would lie below the horizontal asymptote. So those give us some clues about how to graph when we don't have a calculator. So let's try to do some of them without the aid of a calculator. Here I have A is positive 1 and the base is bigger than 1. The base is bigger than 1. So this has to be an increasing graph because A is greater than 0. A is positive. It's got to be growth in the positive direction. So we could say positive growth. The asymptote is negative 2. So let's go sketch that in. Negative 2. And we have positive growth. Ooh, I'm not very good at doing this. You can do better on your paper. So we're increasing, we got positive growth, and the end behavior, they want us to say the end behavior. As x goes to the right, y goes up. So we're lying above the horizontal asymptote. And as x goes left, y is going to tend toward the horizontal asymptote at negative 2. So positive growth. On this one, for B, A is negative 1, so we're going to have negative. And our base is E, so that's a number bigger than 1. So we have negative growth. This is negative growth. So think about it. Growth looks like this, but that negative is going to flip our graph over, and that's going to cause our graph to flip over the x-axis. So it's going to look like that. But it's got shifted up to 3. So 3 is our horizontal asymptote, and the graph would go somewhere, here. See if I can draw that a little bit better. Like that. So you don't need a calculator. You could make a table if you needed to. So we have negative growth, and they want us to say the end behavior. As x goes right, y is unbounded downward, and as x goes left, y is heading toward positive 3. So it's a decreasing function. It's negative growth. The base is bigger than 1. and the A value is negative, which is what's causing that negative growth. All right, letter C. We got to first remember to resolve the negative on the exponent. So our function isn't 1/2 for the base. Our function is really 1/2 to the -1, which is 2 to the +1. So this is going to be positive growth because A is 1 and the base is 2. So we have positive growth. So that graph's going to look like that. Horizontal asymptote is at 0. And yeah, positive growth like that. It's an increasing function. It's concave up. When x goes right, y goes up. And when x goes to -infinity, y is almost at 0. Okay, so this one is going to be exponential decay. You have to take care of that negative. So this is going to be f of x. And we could say this is 2 to the negative and then x plus 2 power. So that negative here is going to cause this to be 1/2. And then that's going to make x plus 2 and minus 3. And really, we just need to concentrate on, first of all, the A value is 1, and the base is a number between 0 and 1. So we have decay, and we have a positive direction. So this is positive decay. And that would be something along the lines of radioactive material. Oh, wait. Got to move that down, don't we? That needs to go down to 3. -3. Okay. So we're really close here. Sort of something like that. So we have positive decay, and it's a decreasing function. When x goes right, we should head toward the asymptote, and when x goes left, the graph would be unbounded upward because it's a decreasing function. Positive decay. In this one, the A value is -1, so it's going to be negative, and the base is a number between 0 and 1. So we have negative decay. There's a horizontal asymptote at 2. And that tells me that the graph, because it's decay, the graph is going to, and the A value is negative, the graph will lie below the horizontal asymptote. So it's going to curve along here. Like that. It would be an increasing function because the negative took the decay function and flipped it across the x-axis. When x goes right, the graph heads toward the asymptote, and when x goes left, the graph goes down. And then our last one, again, we have a negative on the exponent, so we have to resolve that, which makes our base 1/3 to the positive x. Our A value is 1, so it's positive, but the base is a number between 0 and 1, so we have decay, positive decay, with a horizontal asymptote at -2. Are you catching on how easy this is to graph without a calculator if you just know kind of the tricks? piece of cake. So we have a decreasing function. When x goes right, y heads to the horizontal asymptote, and when x goes left, y is unbounded upward. Positive decay. All right, let's see. So let's work backwards now. This time they've given us the formula telling us that the x is a negative number. So this is going to be a decay, right? We're going to have, well, maybe not. Maybe not. Let's think about it. If a is negative, because it's below the asymptote, the graph lies below the asymptote, that's how we know a is negative. And let's think about this. B has to be a number that's between 0 and 1. But because there's a negative x, that's going to make another reflection. So this is negative, and we're going to start off with a number between 0 and 1, and that negative is going to turn that into a base that's bigger than 1. So we have two reflections. So it's a growth. So this is causing it to not be a fraction anymore, or it's causing it to be a number bigger than 1. So we're going to have a growth, but it's going to be a negative growth. And how do we know that? Because you notice that we're moving toward the horizontal asymptote in the negative direction. We have negative growth. And the graph is moved away from the x from the horizontal asymptote. As x goes right, y goes down. But as x goes left, y goes toward the asymptote of 2. And the c value, we know c is 2. We know c is 2 because 2 is the horizontal asymptote. So c is 2. Oh, and I wrote this down here. When x goes left, y heads to the asymptote. When x goes right, y is unbounded downward. Okay? So we can go both ways. Given an equation, you can make the graph. Given the graph, you can analyze based on your knowledge. So this table here goes back to those graphs we just did. And this one, the base is 1.5. This one, the base is e. This one, we have to get rid of the negative, so this base is 2. And if you go back to check the graph, this graph would have been positive growth, so it would be increasing. This one, the a value is negative, so it would have to decrease. And this one, the a was positive, so we would increase. I'm going to abbreviate. It'll look prettier. Decrease. This one's increase. This one's decrease. This one's increase. And this, the graph went toward -2 and then up. This one went to 3 and then down. And this one went to 0 and then up. Okay, on the decay ones, this is 2 to the -1, so that would be make our base 1/2. This base would be 1/4. And this is 3 to the -1, so our base would be 1/3. Here my a is positive, so I'm decreasing. This one, a is negative, So A is -1. It's going to turn that into an increase. And here A is positive, so we would have a decrease on this one as well. So these would go to infinity, and then -3 on the right. And then this one would go from -infinity up to 2. And this one would go from positive infinity down to -2. See, I'm thinking about whether they're lying above or below the asymptote in each case, and you could go back and check those. See, this decay one, the negative caused me to lie below the asymptote. And this one, our A was positive, so I'm above the asymptote. So you just have to put all that together. And here's our final example. So this case, they've given us the formula. We want to use that model equation. And we want to write the equation for H if we know a few things. And we know H of 0 is 3. And looking here, they're telling us that we have an asymptote at 4. So we know C is 4. And we could use this first piece here with C being 4. And if the B value is raised to the 0 power, when Y is 3, then 3 minus 4 is -1. So A is -1. And then for the second thing we'll do is we'll come back and we'll use this piece of information. So now we know H of X is -1 times B to the X plus 4. But we know that H of -4 is -3. So Y is -3 when we have -1B to the X power plus 4. So taking this 4 to the other side, we have -7 is -1 B to the -4. So if we divide by -1, 7 is 1 over B to the positive 4. So B to the 4th is 7. And if we take the 4th root, B to the 4th is 1 over 7. 1 over 7. On my calculator, you check to see if I'm getting the same answer as you. I have this value for my B value. That tells me that our equation following that model with A being -1 and B is 0.614788 to the X power, and the horizontal asymptote was 4. This should be our equation. And if you graphed that on your calculator, you can check while I draw a picture. We should be able to see 0, 3 on the graph and -4, -3 on that graph. It should be an increasing graph and have an asymptote at Y equals 4. So this equation should match up with the calculator. And that's just some helpful hints for how you can graph exponential functions without the aid of a calculator. Now we're truly finished with Chapter 3. See you on the other side of the test. Good luck.